Hello. Hey guys, how's it going? We're almost to the end, and thank you guys for coming here again. And we all appreciate for you attending attending DEFCON this year. I think we're all having a great time, and thank you for being really cool about it. All right, so our next speech, our presentation is ExtensionLand, Exploits and Rootkits in Your Browser Extensions by Barak Sternberg. He is your father. Oh.
Well, I'm super excited. This is my first talk at DEF CON ever. So with this in mind, so we are going to get started. So ExtensionLand exploits and rootkits in your browser extensions. So first, a little bit about me. So I'm a security researcher. My name is Barak Sternberg, and I'm a founder also at Wild Pointer. I was previously an author at SentinelOne Labs. I did this talk about hacking smart devices for fun and profit last year in the amazing IoT village. And I did my master's on algorithms, and I love vulnerability research, from IoT to embedded devices, Linux, web apps, and much, much more. So with that to conclude, I'm also a DJ and party lover, so check out also my Mixcloud for more mixes and stuff like that. And with this in mind, let's start. So our motivations for extension is, well, first, we have more than 2 million extensions in the web stores out there. So we have so many extensions, many are malicious. We all know about malicious extensions, right? And why they are so commonly used for malware. So first, they have so much permissions. You can easily UXSS, you can easily run JavaScript code inside any region targeted with Chrome extension in mind. They can let you control the entire browser and much more. They are stealth in a sense, and they are cross-platform. So they can run on any desktop OS, like, I don't know, Mac, Windows, whatever. And they are really easy to develop. Like, js-malware is much easier to develop than C malware, right? And why did I focus on researching extension? Well, first of all, I love this idea. It's like JS of cool things inside of them, cool APIs, interesting areas to explore. And the main key points is that these attack surfaces inside of them have new, interesting, well, not new, but interesting and unique APIs. And they lie in different contexts, and they have these super browser powers. So let's now talk about these super browser powers, but before that, I'm going to give a brief talk about speech about my talk. So we are going to start with introduction over Chrome extensions. We're going to start with the anatomy of Chrome extensions in general, extensions communication. After that, we're going to exploit 2 different extensions in cool new context. So the first one is the Zotero extension, and the second one is the Vimium extension. On the first, we will jump from one Chrome app to another Chrome extension, elevating our privilege like a PE kind of style. The second one is the Vimium. We use it to get UXSS. And finally, we will kind of bypass the signatures of the extension check inside the Chrome browser. And to do that, we will modify kind of a technique that will help us to change previously installed good extension, converting known installed extension into bad ones. So with this in mind, let's get started. So extension anatomy, the basics. First, like extension are developed of 2 main components, if we generally speak about that. So content scripts and background context. The content script is like the front end, so it's temporarily loaded, and it's temporarily loaded kind of inside every matching sites. So for example, you have a site that is matched for specific extension, and the extension declares this is a site that is matched to. Then the content script gets loaded, JavaScript will get loaded, and they are accessible to the site's DOM and many more things. And there is also the background context. So the background context is actually kind of the back end of the extensions themselves. They run in specific process, specified dedicated process, and different contexts, and they are also persistent. They run once persistently in the background. And to conclude, extension directory is, well, I focused on Windows, but it's truly applicable to more operating system running Chrome with extensions feature on desktop. And the extensions directory lays inside this folder. You can see the local app data here. They are kind of unpacked, all the JavaScript and stuff is in there. They have the extension manifest, if you know, like the manifest inside, I don't know, Android, the XML file. So it's the same, it defines permissions and more things. And they have also signatures. So at runtime and also while installing, this signature gets verified and all the time kind of checked. Cool. So manifest anatomy. So this is the manifest. It composed like of three main things. The JSON file. You have the background. So the background consists of the scripts that used to run in this context. So the first, you can see the background scripts that should be run there, if it's persistent or maybe triggered by something else to be run in the background. Content scripts are the scripts that, well, run temporarily as the front end in the matching sites. So the interesting thing here is you can see the JavaScript here. You can see the JS file gets loaded and in which sites they should be loaded. So you can see it here. And the last point is the web accessible resources and the permissions. So permissions, as you might think, is actually the permissions for the extension themselves. It can consist of cookies, storage, history tabs, and much, much more. Also sites that are accessible. Also, I can give a hint, also file origin URLs and stuff like that. And web accessible resources are actually cool kind of resources that the extension exposes to other websites. So for example, you can add in your site in an iframe or open new window with accessing this Chrome extension URL. Very cool. Okay, communication in ExtensionLand. So let's say we serve to Google, and now the extension, all the extension that's configured to run in the Google context site gets loaded. So you can see here two different parts. The parts which is the web context. It consisted of the DOM area, which is like all the elements of the HTML and stuff like that of the google.com site, and also the page scripts that run inside Google that refer to it and do some changes in there. But the main interesting thing is that on the right side, you can see that there are the content strip of the extensions that get loaded in the context of google.com, but in a separated origin, the extension origin. And you can see also that the content strip can communicate between the background context. And why is that? Because the background context have much more kind of access to more permissions, can do more things, it runs persistently, it can update more stuff. So we have communication between content strip and background context, we have communication between the content strips and the sites themselves, and also I will show more communication ways. So communication between websites and the extension's content strip. So considering that, we have a couple of ways to do so. The first is maybe, well, cross-origin messages. We can just do, JavaScript post messages in between content strips and the sites themselves. You can do post messages in between them, define message listener, and just communicate easily. Also, DOM changes. Sometimes DOM mutations, events, and even the elements and the classes themselves are inspected fully by the extension's content script. And it's really interesting attack surface to explore. So for example, if it gets some data from there and try to do a couple of things because of that, it might be a really good surface, right? So this is the DOM mutation. And last is the thing I talked to you about is the accessible URLs. So the accessible URLs are the URLs you can add to your site that are internally inside the extension. So you can use them and add them, for example, as an iframe. You can open a window with them, and much, much more. Cool. So this was content strip versus websites. Now, websites versus background context. So first, there is like cool things inside the background context. For example, hooking proxy and proxying request between the site that is being now shown to the user and the background context itself. So for example, the background context can hook some request being fetched, I don't know, resources when they being fetched, and then do some operation considering that. Also, the background context have access to all kind of information. Sometimes, depends on the permission, of course, tabs, cookies, storage, and much more, and inspect them. So it can be a very, very cool way to gain more things to do in the attack surface scenario. Cool. And the last bullet is a thing that can be also specified in the manifest. These are externally connectable pages. And by externally connectable pages, I mean, well, it's not the accessible URLs. It's pages that can actually do message passing to the background context and bypass, in a sense, the content script. So you can define in the manifest sites that are accessible to the background context and can send messages back to it. Cool. So it's exposed with the send message API, and the manifest state which sites are accessible to this context. And last, the extension versus extensions. So many extensions can communicate with other extensions as well, and the way they can do it is first all the ways I told you about. Websites between extensions are actually kind of exposed to these extensions as well. The second thing is the externally connectable sites. So the cool thing, well, I'm now skipping over to the last bullet. You can actually kind of do cross-extensions message injection. And the way you can do it is because, well, if, for example, one extension define one site as externally connectable, you can inject in your first extension to this site new script that triggers messaging passing to the other extension. And that way you can send message directly to the background context of the other extension from the first extension. So this is a cool way to communicate between the first extension and the background context of another extension. Of course, only if defined and the manifest. And last, the TCP and UDP connections. Many of them use open TCP connection, communicate and connect to other things and stuff. So that's really cool thing, an attack surface to explore. Cool, let's now start with exploiting Zotero extension. So Zotero extension is actually kind of an academic extension. It helps you get identifiers for specific papers and let you easily manage all your citations in one place. Actually, really easy to do. When I did my master's, it was amazing. Like, use these citations fully embedded and shareable anywhere. And it works also with companion Zotero desktop, which is a software and communicate between them, but it's not a mandatory. So extension like this sometimes and actually usually works independently on its own, and it communicates through a TCP port. So one of the cool feature inside this Zotero extension was actually its translators. It has translators, but not like translator from French to English, but more of like extractions to identifiers inside the web. So you have this translator that is a JavaScript that is loaded inside the content script of the current site and try to extract identifiers that are related to citations. So you can use this translator to extract more identifiers and help you citate more papers and such. But the cool thing about this translator is, well, it's an open source thing. There are more than 500 JavaScript translators in GitHub, and they are open source. And whenever you update one of them, it can run over in any site when Zotero extension is installed. So one attack surface I'm not going to talk about fully here is the supply chaining of these kind of things. And it's really suspectable because it's open source and you can change the JavaScript translators in there. But leaving the supply chain attacks, let's go to another cool thing inside there. So the Zotero translators also have this cool system in which they can update their new translators. So you can call get translators, and you call it like through TCP to the localhost. And why it does that? It does localhost communication because it thinks that the Zotero desktop version might be installed there. So it tries to communicate between himself and the Zotero desktop version, and he reach out to localhost at this high port, and it looks for new translator. So if there is a new translator, it just downloads it and run it over. Oh, that's amazing, right? So yeah, exploiting it. So we're starting with a cron map that listens over a TCP socket, and we just wait for Zotero to act up. When he acts up, it looks for new translator, download our new translator because we made him to believe that we have newer translator to download, and then it just downloads it up and run it. But wait, we actually have inside there Sandbox Execution. You can see here that they actually written here Sandbox Manager kinda, and they try to do eval, which might be not that bad in the Sandbox Manager kind of thing, but it actually doesn't do nothing. It just removes some JavaScript variables and just execute your JavaScript in the content strip context. So that way we jump from the Chrome app, into the Chrome extension Zotero. So now keep in mind we are inside the content strip of the Zotero. We are aligned inside the content strip, but we are not that persistent, right? We want to have more permission, we want to run in the background context. So I was in this point and I was like, okay, let's see what is the attack surface inside the content strips. So inside the content strips, we have now much more attack surface. And why is that? Because now we can send message to the background context. We can also access to some shared extensions URL because now we are running in the Chrome extension origin. So maybe SOAP kind of interesting thing, we can bypass, I don't know. And also there is a storage and configuration thing. And I started from the end and just tried to look for eval inside the background context and just find out I don't know, Google Docs integration system, probably run code integration system, I don't know. And they just doing eval in the background context. And I tried to figure it out why they do it. So Google Docs have a specific integration system inside Zotero. So Zotero tries to integrate it in other manner through its own JavaScript files, and it actually can update these JavaScript files, yes, again, from some repo. But in this case, this JavaScript file gets downloaded from configured URL. So we can't just listen to some port and do what we did the other day. We need to find new mechanism to exploit it. So you can see here, it downloads it finds out the new code repo URL in the background context and download and inject the script here. Very cool. But how can we change this configuration? How can we make this configuration exposed to us? So actually, we don't need to do so much work. The configuration is already available for us. And the cool thing is that this is a new kind of attack surface in respect of Chrome. You can inject configuration from one context, and it will appear in the background context as well. So this is exactly what I did. I injected new configuration value in the content strip to say to him, yeah, I got new repo URL. Yeah, that's cool. Update my JavaScript from there. Yeah, why not? And he just updated it. So to conclude this jump from content script to the background context, what I did was, inject new configuration for this Google Docs integration URL, and Zotero background gets loaded, restarted, whatever, and it just fetch my repo, my new kind of malicious repo JavaScript, and execute it freely in the background context. So this is the full chain from one Chrome app to the background context of Zotero extension. And the amazing thing is that it's also persistent because the background context in Zotero gets loaded every time this Google Docs integration, and it also gets loaded anytime Chrome starts. So we can just sit freely and easily in the background of Zotero that way. Cool, so now I will show you a demo video of how it looks like. So the scenario is that the user installed a Chrome app. We jump from one Chrome app to another Zotero Chrome extension, and we open this TCP localhost. We inject the JavaScript to the translators, and then we inject the configuration. We bypass the things to get from the content strip to the background, and then we run the background contents, and I will show you how it looks like. So here you can see, this is Mappy2, my app. Really, really good app. No permissions, it only have permission to see TCP. You can see it have no access to any site whatsoever. And now I'll go to the Zotero extension, the Zotero connector. And you can see it can have access to all sites with your all browsing history and stuff. And now I'll show you what happens after we've injected our code inside Zotero extension and how it looks like to naive user. You can also see that nothing is shown here, and now things have already run. So you can see here that my CNC gets like new data from the site whenever this site gets loaded and run away. There is no evidence in the DevTools nowhere, because I actually open new different contexts and send all the data from different VM JavaScript contexts, so you can see nothing in the DevTools. And that's it. You can surf, and you can just see everything back in the background. You can see DevTools is nothing, and then I show that it sends my data back to my CNC server. Okay. Oh. Yeah, and this is my CNC server back. Cool. Okay, so this was the first exploit, Zotero extension. Now let's move on to another extension, the Vimium extension. So the Vimium extension makes your browser a Vim-like kind of thing. So you can edit, jump, and search for new kind of things inside the browser. So for example, if I click some button while I'm having this Vimium extension, I can just go and navigate easily with my keyboard without mouse and without anything. And it's a really cool thing because it makes my browser Vim-like. That's really cool. So now our goal is to exploit it. And our attack scenario here is slightly different because I want to show like interesting new kind of vulnerability that depend on the communication inside this extension. So the attack scenario is user enter your site, execute my JavaScript, and my goal is to exploit the Vimium extension, well, to bypass SOAP, to actually do kind of UXSS. So let's consider the widgets. This is like the GUIs inside the Vimium. You have the Omnibar widget, you have the helper widget, you have visual mode. I don't care about them. I care only about the first one. This is the JavaScript run code widget, and this is the Omnibar widget. So let's see what is the Omnibar. The Omnibar is actually kind of a bar you can open up when you click O, and it opens up this bar. You can see it on the left. You can search and jump to sites and do many, many things. So then when you click O, the Vimium content scripts, you remember on the background, catch the keyboard you pressed, and then just add the Omnibar iframe, which is an accessible URL. So it adds this iframe, and after it does that, it just authorizes to this iframe. It sends to him, okay, I have this Vimium secret, which was in the background context was already initialized while Chrome was running the first time, and it authorized it, and then just send commands to the Omnibar. It just send commands to trigger search query, to do things, to search for web request, whatever you want, web resources, and it's really like cool attack surface. So I was saying like, wait, like why not exploiting it and try to communicate and increase our attack surface to communicate freely into the Vimium Omnibar. And that's exactly what I did. So the exploit idea was, let's insert our own Omnibar iframe because it's an accessible URL inside our page. Now let's try to connect to it with the post message and try to send maybe a fake secret or something to bypass authentication. And now we can send commands to this Omnibar thing. Cool. So unfortunately, or fortunately, the Vimium secret is generated really in a state-of-the-art random number generator. You can see that math.random is being used, JavaScript math.random. And man, this one is like kind of easily breakable if you are in the same process like soul shift algorithm. It's like really cool thing to exploit, but unfortunately it runs in different contexts and initialized once in the background context of the Vimium. So I couldn't easily like break it like using like known breakers because it's not in my process. The seed of the random itself is in another process, so I can't easily break it, but like it's only 2 billion kind of numbers, options. So yeah, you guessed it right. Let's just brute force it. So this is the brute force code for like exploiting Zotero and finding the secret. And if success, I get this channel open. If not, no response. And you might ask yourself like, wait, Barak, come on. It would take so lots of time. But the thing is that, well, first, not so much numbers. And the second is that we can use web workers to increase the way we do this brute force. And now, why we do that? So remember, if we run like JavaScript, it can sometimes like stop from running because we waste too many memory consumption, CPU consumption and stuff. But with web workers, we can just easily trigger over and over this brute force from the back end of the web workers, which is supposed to run all the time. So I only need the browser to stay up. I don't even need the screen to be open. And I don't even need my tab to be open. So just keep the browser open, I'll brute force it, and that's it, Gil. Amazing. So we've managed now to brute force and break the Vimium secret. We can communicate freely to the Omnibar iframe. But what commands this iframe supports, right? It might have a lot of attack surface to explore, and it might be very cool to explore this attack surface. So first, it can trigger a search for new URL completion. It can activate a search and jump to new URLs, and search for ints to auto-completion and stuff. Yeah, and we'll also run JavaScript code. This is what we are about here, right? So how we can do that? Just search for the JavaScript scheme, and voila. So you can see that it actually triggers JavaScript execution, but in my site. Well, I don't want to run JavaScript in my site, what it gives to me, right? So I'm in my page, I'm running this Omnibar iframe, I communicate with him, and I trigger alert in my site? No, I don't bother it. But let's now see what happens behind the scenes with this communication. So when we trigger this search for new URLs, what's happened is that the Omnibar iframe tries to find auto-completion for this scheme. So the content script of the Vimium sends message to the background scripts to find relevant auto-completions. Now the background script sends message back to the content scripts inside this tab, to the sender in a sense. But then all the content scripts inside this tab get the message, execute this JavaScript inside this frame. So you can see the problem here? Well, the main problem is that if there are more than one content script of Vimium, we can actually trigger another content script to execute our JavaScript from another. What we will do is trigger auto-completion for JavaScript from one content script, and the background context will send message to another content script. And the reason it happens is that send message doesn't have they don't have any validation to any things inside there. They don't validate the origin, they don't validate the sender in a sense, so it gets sent to any of the content scripts inside this Vimium area. So exploit, we just insert our targeted origin as an iframe inside our page. We trigger the Omnibar bypass authentication, and we then activate the search for JavaScript scheme with our own JavaScript code to be run inside of it. And then it just trigger JavaScript execution inside another page. Cool. Let's see it in a high-level kind of picture. So the Vimium content script gets triggered. The content script sends a message from one iframe, the top iframe, to the background context. Now the background script sends message back to the tab, which appears here. And you can see that the iframe, which is a sub iframe here, gets the message also. And also the parent iframe gets the message as well. So what we do is actually trigger it to make messages to another iframe, and we manage to execute that way JavaScript in another target origin. Cool. So concluding this, the full exploit to bypass SOAP using Vimium is first you break the Vimium secret, you insert a Omnibar iframe inside of you, communicate it with freely because you break the secret. Now you trigger the auto-completion for JavaScript scheme, and when the response gets back, the targeted origin get it and execute our JavaScript. Very cool. Now let's see a demo of that. Okay, you can see here, this is Vimium, which actually got updated and fixed. okay, this is my site, and here you can see that code was run inside facebook.com. And you cannot see here any signs of facebook.com because it's a hidden iframe inside of me. And you can see, we can cover it, but you can see the Vomni bar with the JavaScript scheme and the code I wanted to run inside of it. So we can actually cover it and make it like seem really, really good and really easy to exploit. Cool. So we exploited Vimeo. Now let's move on to the last step. What I want to show you now is kind of a new trick to bypass signature and replace and modify extensions, previously installed extensions in your browser. And well, the scenario here is a post-exploitation. So we managed to run code on the user's device. We already installed a persistent rootkit. We want to install the persistent rootkit. And our goal is to, well, of course, use extensions to install a persistent rootkit inside the browser. And one of the things I'm going to show also that, well, we can install persistent JavaScript rootkit, which can be accessible also to the file system, read access, cookies, tabs, passwords, much, much more. And it's still because it's running the Chrome context. So yeah, again, keep in mind extensions are signed. So once you install them, they are continuously get verified. So even if I change them in the runtime, Chrome will just say, okay, signature is not good, and it doesn't run the new JavaScript. But extensions in unpacked mode, well, apparently there is like a cool mode for developers in which they can develop their extensions, and this unpacked mode gives them the opportunity to not sign their extensions and just develop them easily. So if extension gets loaded as in unpacked mode, which is an easy argument to add to your Chrome, and a good way to do red team or pen testing, I guess, you can actually replace or add new extension that is easily modified and not signed. But the even more cooler thing is that you don't need to add new extension to do so. So, exploiting. Let's pick an already installed extension. For example, you have AdBlocker, Google Docs, any other extension. And what we will do now is actually try to reload it in a sense while making Chrome thinks that it is unpacked mode. So we will load this extension. You can see the argument --load extension, and it points out to the original extension folder, to the original extension there. So we don't even need to add our own files or anything. And while we do that and run up Chrome again, it just doesn't verify the signature for the previously installed extension. And this extension, I will show you, it seems exactly the same. Chrome thinks that the good extension is installed and seems like it's, well, all good. Cool, so let's see now a demo for that. This is my Chrome. And you can see my ad blocker is the target, installed, Chrome thinks it's installed correctly, all good, no problems. And yeah, the original site in the web store. And you can see here that it's also like seemingly almost exactly the same besides a small tiny icon in there, but it's only in the extension area, and Chrome doesn't give any warning about that when you open Chrome or anything like that. It seems exactly the same. And you can see here below, I moved on to the background context. This is what you see here. And you can see that my JavaScript was executed in this terminal console. You can see it below there. So I'm injected my JavaScript code inside that ad blocker. It seems exactly the same. You won't even notice. Like if you investigate it statically and see what extensions are installed, you will see this one and all good. No signature verified. And yes, we can also enhance our permissions. We can also, this technique, change all the manifest file. So this leads me to, well, my final thing here. I developed also a tool you can enter and use it. It's a POC kind of thing. And it's called Maltensions, and it's a cool tool to generate your own malicious extensions for the browser. You can use them either as a JavaScript you can add over to the background context of some already installed extension with the unpacked mode, or you can either use it as a new extension you're trying to install. And its feature consisted of, well, you can inject and run JavaScript in hidden context. There are several techniques there in the modules directory, and you can have file system access with file origin URLs because I can increase my permissions with this post-declaration method. Access to sites, stub, user storage data, and much, much more. It contains also simple CNC communication. So, conclusions. Well, first, yes, extensions are and can be exposed much more to PEs. PEs through extensions are possible in a sense you can elevate privilege from one extension to another. You can gain more privileges if you develop seemingly harmless extension and moving it from one extension to another. The second thing is, well, unfortunately or fortunately, depending on which side of the map you are, the detections will get much harder. So detecting these kind of things is harder because you see Chrome things, the original one is installed as and all good. And also so many, you remember the 500 translators in JavaScript that run on over 3 million users. So they are all exposed, and I don't know what is inside all of these 500 translators. So detections will get harder. Third, there are much more attack surfaces to explore. So we have so much more attack surfaces, communication, and much, much more. And last, well, malicious extensions are here to stay. It's about time we investigate and research much more inside of them and try to find out how we can protect and defend more regarding and considering them. Not just from known malicious installed extension, but more even about their communication and the dynamic and much more things they do inside of them. Okay, so with that in mind, thank you so much. It was a pleasure. It was my first time speaking at DEF CON. I'm so excited. I'm here if you have any more questions. So my name is Barak Sternberg. You can look me up in Twitter, Live in Beef, and well, that's it. Thank you.